This is Makeathon 2022. We're doing the AEP Pseudo-Wind Tower Challenge, and we're the cool Cathodes.
In reality, wind turbines have many conditions that one needs to consider for proper operation and safety. External and internal temperatures and speed of wind and rotations allow us to make sure the wind turbine is operating in safe conditions. The vibration of turbine blades that we measure can allow us to make minute adjustments to the turbine blades to ensure optimal power output. Humidity and air density also affect the power output. By measuring the actual power output, we can measure the actual efficiency and the actual power output of compared to the expected power output.
We have a phototransistor taking samples that are being converted to the average RPM of the wind turbine blade over a span of 60 seconds. This tachometer is being used to measure the speed of the wind turbine blade and is used to determine when the speed breaches a high threshold level. Once this high threshold is breached, we have set a step motor to turn off our wind turbine. This is important because the remote deactivation of the turbine will prevent the technician from having to immediately travel out to the site to troubleshoot.
All right, this is the demo of the temperature sensing circuit. So the way this works is that we have two thermistors that are measuring the internal and external temperatures of the turbine. This is the thermistor measuring the ambient temperature, and then we have one that we've slotted into the casing measuring the temperature of the motor in this fan. And by hooking this up to the Arduino, we can use it as a data logger to track the temperatures in real time. And the blue curve is the temperature inside the motor, red is the ambient temperature. Running the motor for long periods of time will increase the temperature, and if the temperature increases beyond a certain threshold, it will turn off the turbine.
This is our microphone sensor. It is wired in an op-amp circuit. When the sound from the blades gets dangerously high, it will initiate an actuation in the circuit, turning off our switch and keeping the turbine at a safe sound level. This is the data collected from our microphone sensor. As you can see, when the sound gets too high, there will be a stop in the serial data, and our fan will be turned off due to high noise.